For the 39th problem on the second ACT practice test, in the figure below, line L is parallel to line M. Transversals T and U intersect at point A on L and intersect M at points C and B respectively. Point X is on M, the measure of angle ACX is 130 degrees, and the measure of angle BAC is 80 degrees. How many of the angles formed by rays of L, M, T, and U have measure 50 degrees? So to answer this question, let's first look at the properties of parallel lines that have a transversal crossing them. So if I make a little bit of room down here, I can draw a couple lines, and we can assume that these lines are parallel to each other. And we can have a line crossing them, where this line crossing the two parallel lines is called a transversal. So the green lines are parallel. I'll denote that with some arrows. And what we want to look at is the different angles that are formed by these transversals. So if we start by looking at this angle here, we want to figure out which angles are also equal to this angle. And we know that vertical angles are equal, so these angles here are equal. But one property of parallel lines that are crossed by transversals is that alternate interior angles are equal. So this angle here would be equal to this angle here. And again, because of vertical angles being equal, this angle will be equal to the other three angles. And now, essentially, just looking at the supplement to all these angles, so this angle here, actually let me use a different color for that. So we have this angle here would be equal to this angle because of vertical angles. And we know that alternate interior angles are equal as well for these parallel lines. So this angle here is equal to the other two. And then we have this angle as well because it's a vertical angle to this angle. And what's unique about these two angles is that they're supplementary, meaning that these two different colored angles add up to 180 degrees. So now looking at our particular problem, we have these two parallel lines, L and M, and we have these two transversals. But let's first focus on the transversal T. So we have this angle here, and this angle right here would be a supplement to this angle based on the properties we just examined. So by supplement, I mean that this angle and this angle add up to 180 degrees. So that would make this angle 50 degrees. And if we know this angle is 50 and this angle is a vertical angle, that means that this is 50 degrees as well. Now, all of the angles that form a line, so in other words, this set of angles here, these would have to add up to 180 degrees. And we know this one is 50 and this one is 80, which is 130 when you add it together, which means that for all three of these to add up to 180, this would have to be 50 as well. And again, since this angle here is a vertical angle, this is 50. And focusing on this transversal T again, if this angle here is 50 degrees, then this angle has to be 50 as well, since they're alternate interior angles. And you can make the exact same argument with this transversal U and this angle here and this angle here. These are both alternate interior angles. So again, we have 50 degrees. And this angle here would be 50 since it's a vertical angle. And the same could be said about this angle here since it is vertical to this 50-degree angle. And just by looking at the rest of the picture, it looks like this is the total number of 50-degree angles. Since you could actually calculate the rest of the angles. Like this angle up here would be 80 degrees since it's a vertical angle. This would be 130. This one right here would be 130 since it's supplementary to this angle, which implies that this angle here would be 130 as well since it's vertical to this angle. So that concludes finding the measure of each of the angles, which means we can just count how many 50-degree angles we have. So we have 1, 2, 3, 4, 5, 6, 7, 8. So our final answer here for how many 50-degree angles we have is this letter C.